Okay, so what we're going to do here today is I'm just going to go over the logical network and the basic design. So what I've come up with is I have two examples here that I've designed based on my experiences. Now this translates and is adaptable to many different environments. But what I've done is I've come up with this one based on a remote site where you would want to have all the infrastructure living on the site and not in the cloud. You would probably be backing up to the cloud or possibly have a hybrid network design. But we're not going to go into that so much. We're going to focus on just the design concepts. So as you can see on the screen in front of me here, there's a site-to-site link. That would be wireless equipment of some sort, either put in by your telecommunications provider or by your own IT team. But that generally would be a microwave link between sites. Immediately after that, you would be connecting usually by fiber. I've highlighted anything in fiber is in orange, anything in copper is in blue on this diagram. It's good to keep your communication types or media coded separately in these designs. So you'd be hitting a firewall. Then from there, you're going to be hitting a fiber switch. And from there, that you would probably go directly into the core router. Now there's more than one way to skin a cat, pardon the expression, but it's been around a long time. This is just a design I'm using for an example. So from there we go into the core router, and from the core router I would be using fiber out to my switches. I would also be assuming your core router has multiple fiber outs or a bank of it, like it's a Cisco 4000 series, I think it is. You would have a whole bank of fiber leaving there. So it in turn would be your primary fiber switch. So assuming your core router has at least a couple of fiber out, you're going to be going fiber out from your core router into your other switches, whether they're a fiber switch or a copper switch with fiber input of some sort, either GBIX, SPDIF, something along those lines, or dedicated fiber points. You would be going with fiber to your switches. Now that could also be a stacked switch. It really depends on the size, and it could be going to many switches, or you could be going from into other switches, and those switches could be going into yet more switches. It really depends on the scale of your environment. But for this scale, I have two switches. This is a fiber switch. This is a copper switch. Fiber network, copper network. So basically what happens is the core router comes out, goes into a fiber switch. From the fiber switch, then you've got fiber endpoint nodes, wherever you need a fiber endpoint. Now I did make a mistake on here. Plotters are generally not fiber, but it's not really a mistake because you're probably going quite a distance away in a building somewhere, and you're probably going with a fiber converter to the plotter. So it would be copper on the end of a fiber converter. Then your engineering workstations, because engineering's a heavy workload, heavy bandwidth load, heavy server load. Any engineering machines or heavy workload computers, say video editing, say 3D design and CAD work, you're going to want those directed with fiber at all possible. So those would have a fiber network card in them, and they would be fibered. Engineering laptops, same. You would want those fibered if at all possible. It's expensive to put fiber connections on laptops, but ideally that's the scenario for the engineering department. The phones for the engineers would not be. You can see they're connected with copper to the copper network. So then back from that switch, you have a direct connect into your servers. This would be the engineering server. It would be a fiber connection. You would also have connections going to other servers, fiber back to the core, into the fiber switch, depending. Then that you would also go now into the copper network. Now in the copper network, you're also going to have fiber, which I probably should have put this copper network into the fiber network or straight back into the core, but for ease of diagram purposes, most switches have the capability to run fiber in them, even primary copper ones. So I went with fiber directly into the copper network. Then the copper network feeds out into your Wi-Fi, your business copiers, printers, various offices of printers, etc. your IP phones, your general client laptops, manager laptops, etc., etc. Control subsystems, that would be like machines on the floor controlling processes. Thin client group 1, thin client group 2, and it would also be fiber back into your main server nodes. So that is where primarily your network design is going to be. You would also break those into your VLANs. You would have your, basically your data network would be your VLAN 20, your control systems would be your VLAN 30, and your VoIP phones VLAN 40. You could use any VLANs here, but generally speaking, those are the ones that I'm using. But you could be anything. Generally, you reserve VLAN 10 for your management network, which I don't have on here, but you would. So anyway, that is the first design speed. The next design sheet will be the primary RNC. So you can see I've pulled up the PDF of it. So this drills down even further, and in your design specs you always want to document everything and design things out before you do the build, because these things are not cheap. So what we've got here is the Juniper at the top, which is basically your backhaul uplink. TELUS comes in, or whoever your provider is, Shaw, Sprint, Verizon, whoever you've got for a provider, come into here. From there they go into the core router, which is the next item down in the rack. The core router then is where all your route tables, your VLANs, everything like that's all set up in there, and the traffic gets shaped in there. Below that we've got fiber switch. Fiber switch then goes off and goes in directly into some other devices like servers, storage vaults, etc., or just into other switches, or potentially other fiber switches down the line. A lot of times you'll have a fiber switch in each building, and then it breaks out to there into copper or to various locations. Some of these industrial complexes are very large, so you need a lot of fiber runs in order to cover the distance, and then a lot of times you'll use a fiber converter and switch it into copper at the end run, put it right into the workstation. It all depends on the environment. There's a lot of different scenarios out there. Below that are your switches, and now that generally goes out to your data networks or into your building. So you've got your switches and your patch panels here. Below that you'll have your, and the patch panels are, as we've said in other videos, they're what take the copper back into the building, out to the different workstation areas where you connect into the wall jack. So from the patch panel into the switch, and then from the switches into other switches, and from the switches into the servers and the power vaults, etc., etc. Different storage devices, backup NASs, whatever you've got in your rack. So moving further down, I've got a series of servers of different powers and scope because of what they'll be utilized for in this environment. So media servers, it's like web pages, video playback, training systems, whatever. They don't need a whole lot of horsepower, so those are R230s. Then below that, we scale up into R430s because we need a little more power. I've got that running here, the on-site exchange server. And I've also got a couple of other ones under it because things always come up. You're going to need spares. You may want a redundant exchange server. If you're running in a hybrid model, you would probably just have your redundancy in the cloud. But you know, if you're very isolated, you may want your redundant server there. So then I've got another spare because you've always got a spare. It's probably sitting powered down, but you can move a VM back and forth to it if you needed to, if you were having problems. Engineering software, and I go up to an R640. Oh, which I have a spare R640 sitting above that in the rack as well. A lot more horsepower, a lot more cores, CPUs, RAM. Engineering software is very demanding. So you've got a very skookum machine dedicated purely to your engineering applications and the performance it requires. So often I've come into these mine sites and they have not had a dedicated engineering machine. It has been a VM sitting with other VMs, shared resources, and a lot of times on a lesser machine, like a 430 or even a 310 or something. Not enough power. You need those robust powerful machines for engineering. And you need that robust fiber link, as discussed in the previous diagram, to make sure that you're giving everything you can to your engineering people and make the most out of their salaries and their time on site, because that's where your money is made. Next is a database server. Again, it's Skooka machine. Generally, you're going to have several databases running on this machine. You're going to have SQL databases. You might have post-over databases. You might have MariaDBs. It all depends on the application. You've probably got an Oracle or two kicking around in there. There will be several databases, all with independent connections. That unit's probably got multiple fiber connections, just like these power vaults will. All your power vaults down here are going to have, you're going to have your engineering files kept on one separate power vault, a big storage device, and you're going to have your distributed file systems and your user profiles all stored on another power vault. You don't want them on the same one. You want that dedicated access to those engineering files and everything else offloaded. Then you're also going to want another power vault for your VM backups and your database files. So you're going to need that space. And then finally, at the bottom of the rack, you're going to have your battery backups. Everything needs to be protected 8 ways to Sunday, especially, and I can't emphasize this enough, especially in a remote industrial environment. Battery backup is a golden rule. You always have to have more than enough to cope for your equipment that you have racked. So on that, I hope you join me on the next one, where I'll get into the specific design of the environment I'm building here. So I will lay it out in a chart similar to this, but I wanted to introduce you to the concept of designing the network and giving you the two tiers that I like to use on a little bigger scale. Because what I'm doing here is a very small scale, but can be scaled up. And this is what I consider a medium-sized environment. So I wanted to give you that as an example. So I hope to see you in the next one. Thank you.